Hey guys, Ms. Cochran here, and today we're on our page 11, and I wanted to go back over a little bit of application using a determinant to find the area of a triangle. We started speaking about problem number 9, how this formula works in our video from yesterday, and this is just the formula. You plug in your point 1, your point 2, your point 3, and ones are here. And you find the determinant. Now, we started this particular problem, but we didn't really finish it. We saw that point 1 we could call P and put in the -5, -2, the 3, 9, the 7, -4. And then we know that we're supposed to, for finding determinants, we copy over the first 2 columns and place them to the right. And then now we'll do the down minus up. Now, when I start going downward and multiplying it, that would end up being a -45. The next one would end up being a -14. And then the next one moving down would be a -12. Okay, these are our downs. And then remember, we subtract our ups. So now I'm going to go upward. And moving upward, we have a 63. We have a +20. And then we have a -6 when you multiply those 3 numbers. So once we do that, then I would use my calculator maybe to help do the computing to finish it. So our -45 minus our 14 minus 12, that's going to give us a -71. I'm a little out of space, so I'm going to put it right here, our determinant. We have a -71, and we're minusing, let's see, 63 plus 20 minus 6, that's a 77. So if we have a -71 minus our 77, that gives us a -148, which is the determinant. But that's not the area of the triangle. It said to use this formula for area of a triangle. So for area of a triangle, it says 1/2 the absolute value of the determinant. Well, our determinant was -148, and the absolute value of that is +148. And then if we half that, we get the answer is 74, and this is the area of that triangle. So this is all of number 9 finished, and I hope you were able to figure that one out on your own, just using what we knew and that formula that they gave you guys. Now, I'd like to also talk a bit about number 10. This one, to me, you need a diagram, and you also need to know a compass rose. So just a kind of tiny compass rose right here. We know north is up top, south is down bottom. We know west and east. So I did that just to kind of help you guys. And if you read the problem first, just to kind of get an understanding of what's going on, it says Wells Springs is 14 miles north and 3 miles east of Chester. Hillford is 8 miles east and 5 miles north of Chester. Find the area of the land formed between these 3 towns. Now, it sounds like they're all kind of moving from Chester. So I'm going to put a little mark and call it C. And then I'm going to draw a little diagram, and I'm thinking about what it said right here in sentence number 1. It says Wells Springs is 14 miles north and 3 miles east. Well, north is up, east is this way. So it said 14 miles up and 3 miles east. And this was our Wells Springs. I'm just going to put a little dot and call it a W there, okay, for Wells Springs. It said in the second sentence, Hillford is 8 miles east and 5 miles north of Chester. So east was going to the right, and it said, how many? 8. So it was 8 miles this direction, okay, and then it was 5 miles north. So, and we called that Hillford, so I'll put a little dot and call it Hillford. Now, I did make a little typo when I was writing. This was, I know it was east, but I wrote an E. It was a 3. to the east when I was doing that one. So a little typo on my page. Now it's fixed. And it really wanted us to find the area between these towns. So it's really wanting like this area of this triangle. Okay, so trying to give you a little diagram to look at and use. And then I started looking, thinking, how can I put that in this matrix right here? I need some points. So as I look closer, well, we don't really know anything about Chester. It's like your origin. It's your point 0, 0. Okay, and then Hilford is 8 to the right and up 5. So that is 8, 5. But you've got to be careful about Wellspring because it really moved right 3 places and up. So its point is 314 because we move right and left. That's your X number, and up and down is your Y value. So it was 314. So be careful with that point. Once you have those points, then you can plug it in into that little matrix that they showed us. It doesn't really matter which point you put on top. I've just put the 0, 0 on top, and then the 8, 5, and then the 3, 14. But these could be scrambled up, and it won't really matter, okay? I just want you guys to know at your desk if you did it a little different. As long as you're consistent with your math, it really doesn't make a difference which point is on top, okay? Now, you do have to do the determinant, so I'm going to copy over those first 2 columns the way that I wrote them, and then I'm going to do my down minus up. So moving downward, when I multiply, it's got a 0, so that's easy. Moving downward, that one is also 0 because it had a 0. And then the next one is 8 times 14, and 8 times 14 would give us 112. And it is positive, so I'll put that. Then our next, we've got our down minus our up. So up right here would be 15. The next one is 0, and the next one is 0. So if I add that up, we get a 15 here. If I add that up, we get 112, and you end up with 112 minus 15. So 112 minus 15 is a 97, but that's your determinant. Okay, so be careful with your answers. We're not done with finding the area yet. Remember, the area, it said, was half of the absolute value of that determinant. Well, the absolute value of 97 is 97. So we just really have to half the number 97. So the area of this problem happens to be a 48.5, and that is our answer for number 10, page 11. Now, for the next thing that I would like to show you, I want you to turn over to page 12 in your packet, and let's look at a few things at the top, some little definitions. An identity matrix is denoted as a big capital I. It is a square matrix that when multiplied by another matrix equals that same matrix. So when you multiply by the identity, you get the same matrix. In real numbers, don't we have a number like that we multiply by and we get the same thing? What is it? A 1, right. So identity matrix is really the value 1. Okay, that it's a matrix that means 1. So that's what they're saying here in that sentence. Now, if A is a n by n matrix and I is an n by n identity matrix, then it says that if we multiply A times I, we're going to get an A. Or if we multiply I, the identity matrix, times A, we're still going to get A. Because the identity matrix is really equivalent to the value 1 in real numbers. Okay? Now, in the next thing here, it says an identity matrix contains ones along the main diagonal and zeros for the remaining elements. So a 2 by 2 identity matrix looks like this. It has a 1 here and a 1 here. That's what they call the main diagonal. And then zeros in the other locations. This is a 2 by 2 identity matrix, which really kind of means the number 1 as a matrix. Okay? Now, a 3 by 3 identity matrix has 1s down the main diagonal and then zeros everywhere else. So it would look like this one. Okay? And these are your 2 by 2 and 3 by 3 identity matrices, which really just mean 1. They're equivalent to the number 1. Now, in our next little box, they're starting to talk about inverse matrices. And 2 n by n matrices are inverses of each other if and only if their product equals the identity matrix. Okay, so 2 matrices are inverses if when you multiply them, they equal a 1, they equal the identity matrix. And I'm going to show this in just a moment, but they're basically saying like in real numbers, when we have the inverse, when we multiply something that is an inverse, we will get a 1. That's what they're kind of talking about, but they're talking about it in terms of matrices. So we'll show this in just a second. Now it says if matrix A has an inverse denoted as, they called it B, then when I do A times B, I'm going to get a value 1, which is the identity matrix. And if I multiply B times A, I'm going to get the value 1, which is the identity matrix. Okay? So that's if they are inverses of one another. Now, they give us, in problem 1, they give us 2 different little matrices, and they want to know, are these inverses? Well, in order to do it, we're going to do this like little formula. We're going to multiply them together. We're going to find the product, and we're going to see if it turns into the identity matrix. So we're going to multiply the 2 and see if it gives us the little box like this, the number 1. Okay? Now, so look at this problem, and it is a 2 by 2 with another little 2 by 2, so it does work. We can multiply, and it's going to give us a 2 by 2 answer. Now, remember we do row by column, so we're going to do a -1 times 5, which is -5. We're going to do 2 times 3, which is a 6, and then we're going to like add that up, and -5 with the +6 is the value 1. So, ooh, it's kind of looking like that identity already. But you really have to finish it to see if it works. Now, the next one, we're going to do row 1, column 2 this time. -1 times 2 is -2. 2 times 1 is 2. If I add that up, we're going to get 0. So it's really starting to look like that identity matrix with the 1s down the diagonal, main diagonal, and zeros in the other places. But you really can't stop here. We have to check the bottom also. So we're going to do the second row, first column. So 3 times 5 is 15. And we're going to do our -5 times 3, which is -15. We're going to add that together, and it does make 0. And then our last one, we're going to do the bottom with the column 2. So 3 times 2 makes 6. And negative 5 times 1 is a negative 5. We're going to add that up, and we end up with a 1, which means that when we multiplied, we did get the identity matrix. So it passed the test. This one is yes, it is an inverse of each other. They are inverses. Okay. Let's test problem 2. So I still have a 2 by 2 with a 2 by 2, and I know it's going to give me an answer when I multiply of a 2 by 2. Now, I know we do row by column, so be really careful. We're going to do that. Negative 8 times the negative 6. Okay. What's negative 8 times negative 6? Positive 48, isn't it? Okay. What is 3 times 16? Oh. Uh-oh. There's no mistakes there. Negative times negative is positive. Okay, so guess what? 48 and 48 give us 96. Is this an inverse? No, because it didn't make a 1 right there. It needed to look like this, and it already does not. Sure, we could finish the multiplying, but I already can tell that it is not an inverse of each other. Okay, so let's move to page 13. And on page 13, it has another little bullet. I'm going to let you guys do this one, or we'll come back to it if there's some extra time. They're just going to have you multiply the two matrices and see if it's the inverse. It's just like problem 1 and 2 that we just did. But right here it says, does an inverse exist? And it says, not all matrices have inverses. Matrix A does not have an inverse if the determinant equals 0. So if the determinant is 0, then it does not have an inverse. Okay. Now, this here is showing you guys the formula for finding the inverse. But there is one thing I told you yesterday, I didn't really like them doing that symbol. So it makes it look like absolute value right there. You really are not doing absolute value there. You're only finding the determinant of that matrix. Are you okay with that? I'm changing it on mine, so you might want to change it on yours if you would like. It is not an absolute value symbol. It is a determinant symbol, okay? And we'll do the formula here and show it. But I want you to notice that the down group, they swap places. See the AD, they swap. And the up groups, they don't swap, but they change signs. So they go to their opposite, okay? Now, let's look at problem number 4. We're going to follow this formula. The first step is to find the determinant. So I'm going to do the down minus up. So down it would be 12, minus up it would be 6. 12 take away 6 is a 6. So the first thing I would do is tell that the determinant is 6. Then I would go and plug it in under a 1 for the inverse. Oh, and this symbol with the negative 1 is a way to say inverse. Okay? Do you see the little A with negative 1? That is a symbol that means the word inverse of A. Now, so let's finish this. We're going to do 1 over the number 6. We're going to do a little matrix box. But this time, where 4 and 3 are, they're going to swap places. So the 3 is going to move up top and the 4 down kind of bottom. And do you see where the negative 6 is? It's going to turn positive. And our negative 1 is also going to turn positive because the up groups go opposite. Okay? And then we multiply by our scalar. Now, I have noticed before on test generators that they might leave the answer like this, but it really is unfinished because we know how to multiply by a scalar. So, what is 3 times 1/6? That means 3 over 6, doesn't it? What's 3 over 6? 1/2. 1 times 1/6 would be 1/6. What is 6 over 6? 1 whole. And what happens with 4 times 1/6, which would make 4/6? It turns into 2/3. And this is the answer for problem number 4. That is the inverse of problem number 4. Let's try 6. Do you guys recall what our first step was? Okay, our determinant. Yeah. We've got to find that determinant. So we're going to do 8 times 5 is 40. Minus 8 times negative 10 is a negative 80. And minus a negative really is going to add. So what answer would we get? Okay, 120 is right. That's our determinant answer. But now to do the inverse, we're going to do 1 over the determinant. We're going to, our down groups are going to swap places. So 5 will move up, 8 will swap. So the 5 and the 8 swap places. And the up groups go opposite. So that 8 down here is going to turn to a negative 8. And that 10, negative 10 right there is going to turn positive 10. And the last and final step is to multiply it. Now, I don't have a whole lot of room, but I'm going to kind of write it over here. I would probably go ahead and say it's 5 over 120. It's 10 over 120. It's negative 8 over 120. And it is 8 over 120. And then I would reduce the numbers. Okay? Now, 5 does go equally into 120. So 5 will go into 5 once, and 5 will go into 120. I believe it's 24 times, isn't it? Okay, good. And then notice there's a 0 and a 0. We can cancel the zeros out right here. And so it's going to be 1/12 on that one. And I believe 8 also goes into 120 15 times. Good. So this is going to be a negative 1 over 15, and this one's going to be a positive 1 over 15. And this is the final answer for the inverse of this problem. Are you guys hanging in there okay? I'd like to also do problem number 8 with you. Okay. And looking at it, our very first step would be to find our determinant. So I'm going to multiply down is what? 12. Good. Minus multiply up is 12. And 12 minus 12 is 0. So can I do an inverse? No. This one, because you can't do 1 over a 0, remember, that's undefined. So this one, you can't really finish doing the math. It has no inverse. Okay, so number 8 is a matrix that they were talking about in that little box up top right here. It does not have an inverse because the determinant equals 0. Okay. I would like to do one small other thing with you, and that is, will you turn to your page 16? And on page 16, I wanted us to look at just a couple of these problems in our graphing calculator. I'm going to teach you how to use your graphing calculator. Now, give me just a moment, because mine had some old things typed in it, so I had to maybe clear it. Do you guys see above or below the math button, the key has a matrix word right there. Do you guys see that one? It's the x to the negative 1 power. So in order to get to matrices, we're going to hit the second key because it's in blue, and then that button that's x to the negative 1. I thought I cleaned them out. I did not. So hang on one second. I'm going to clean the calculator real quick so that you guys can see a brand new, it all being typed fresh. Okay, so here we go. I thought I had it cleaned out. So now I went to that second matrix, and mine is all fresh and clean. I just kind of reset it. And in order to, this is where we call up the name after we've put the information in. This is where you have math. CDET is right there under math. It's kind of cool. Move on over. Do you guys see edit? Edit is where you actually enter the information. So I'm going to go ahead and I'm going to show problem number 1, A plus E. I'm going to type in matrix A. Well, so I'm going to hit enter, and notice I'm on the letter A when I press enter. Okay, it's going to call this matrix A. But notice it says 1 by 1. Well, A's not a 1 by 1. What is it? Okay, it's a 2 by 2. You must tell the size correctly to enter your numbers in. Now you just press, it goes across the top, so I'm going to do 1, enter, -3, enter, 4, enter, and -1, enter. Once I have them all in, and I'm satisfied I typed it correctly, I will do the second and the mode button where it says quit. It's like just changing pages. Second, quit. Now I'm going to go back to the matrices. Okay, so second matrix. And this time I'm going to edit and call, I'm going to name it E, and I'm going to go down and type E in. And E is right over here on this side of my page here. So I'm on edit E, and I'll press enter. And it is also a 2 by 2, so I typed 2 by 2. I'm going to enter the numbers now. Okay. And now that I am totally satisfied, I've typed everything, even my negatives, I'm going to second quit just to change pages. Okay. Now I'm going to call up by name A plus E. Okay, so I'm going to go second matrix. See where it says name A? I'm going to hit enter to call that one up. Then I'm going to press the plus sign, and now I'm going to call up the matrix E. So I'm going to do second matrix, but this time I'm going to go down to where it says matrix E, and I'm going to call it up. Notice it typed A plus E, okay, just like we had here. I'm going to press enter, and we have ourselves an answer. Now, in my opinion of matrices, this is a very long process to type them in our calculator. I don't feel like it's a shortcut on all of our math. So just to kind of give you a heads up, could we have done that quicker just by looking at it and saying 1 and 7 is 8, -3 and -7 is -10, 4 and 11 is 15, -1 and -9 is -10. Could we have done that a whole lot faster without typing it in our calculator? I think so. Okay, but I wanted to show you that it is possible to put them in your calculator and then use them. Now, this would be handy if I had them over and over. Like maybe I was wanting to do 2 times A. If I wanted to do like 2 times matrix, 2 times matrix A, then I could name up A and I could do that, and now I'll have double what it is. I hope you guys are happy with that, and I'm going to stop here today. I just wanted to give you a little preview of using your calculator. I will continue a few things tomorrow on our calculator. Your task tonight is to make sure you finish pages 12 through 16. I know 16 was warm up, so you probably have this page finished already. Good luck.